Hello, welcome to my channel. Today we are going to learn how to find the local maximum and local minimum of a function. Suppose our function is f of x is equal to x cube plus minus 3x square plus 2. So to determine local maximum and minimum, first we need to find out the critical points. The critical points are the points C where f prime of C is equal to 0. So first we need to find out the first derivative of f. So f prime of x would be 3x square according to power rule minus 3 as it is, and according to power rule the derivative of x square is 2x. So 3 times 2x would be 6x, and the derivative of constant 2 is 0, so no need to write it. Now let us set this derivative is equal to 0 to find the critical points. Now from this equation 3x square minus 6x, we can factor out 3x. So in the parenthesis we will have x minus 2 which is equal to 0. So we have x is equal to 0 and x is equal to 2. So we have two critical points at x is equal to 0 and at x is equal to 2. So now what will we do is we will take the intervals. The first interval we will take from the minus infinity to the first critical point 0. Second interval we will take from the 0 to the second critical point 2, and the third interval we will take from the 2 to positive infinity. In each interval we will take one value x. So in minus infinity to 0 we can take minus 1. From 0 to 2 we can take positive 1, and from 2 to infinity we can take the value 3. Now we will find out the sign of f prime of x at these values minus 1, 1 and 3. Our f prime is 3x square minus 6x. So 3 times minus 1 square minus 6 times minus 1. So this will be 3 times positive 1, so just 3, and minus 6 minus 1 would be plus 6. So this is 9 which is positive. Now at x is equal to 1, our f prime x would be 3 times 1 square minus 6 times positive 1. So this is 3 minus 6 which is minus 3. It is negative. And at x is equal to 3, our f prime of x will be 3 times 3 square minus 6 times 3, which is equal to 3 square is 9, and 9 times 3 would be 27 minus 18. So this will be 9 which is positive. So we can see that here the sign changes from positive to negative. Okay, so at the point x is equal to 0, we will have a local minimum. X is equal to 0, we will have local minimum. From positive to negative, so local maximum. I will show you why it is local maximum using a graph later on. And between these two last interval, the sign changes from negative to positive. So at this point we will have local minimum. So at x is equal to 2 we have local minimum. Okay, now let us take a graph. Okay, suppose our graph is like this. Suppose this is an approximately graph. Okay, so this point is 0, this point is 0, and this is 1, and suppose this is positive 2. So if we talk about this point x is equal to 0, on the left side the graph is positive, means the tangent line will be like this. Okay, on the right side it is negative, means tangent lines will be like this. So when the slope, means derivative, changes from positive to negative, we will have local maximum at this point. Same way, let us see at the point 2. Okay, at this point on the left side the slope of the tangent line will be negative. The tangent line will be like this, so slope is negative. And on the right side our tangent line will be like this, so slope is positive. So when the slope, means derivative sign, changes from negative to positive, we will have local minimum at this point. Hope this will help you to understand how to determine the local maximum and local minimum using the critical points and first derivative.